Section 4.7 is on special factoring techniques. So this is just a couple of additional ways of factoring things. But these are special ones, meaning they apply in certain specific situations. So first, in order to do these, we need to know, this first one at least, we need to know what our perfect squares are. So perfect square just means it's an integer square. It can also mean that it's some algebraic expression squared, but certain types of them anyway. But these are the ones you need to know. You should know these. So if you see a 169, you should know automatically, like right away, that's 13 squared. 144, you should know right away that's 12 squared. 121, you should know that's 10 squared. And the earlier ones are all in the multiplication table, so most people know those. Make sure that you know all of them. You don't have any holes in your knowledge. Okay, because we need this for this technique that we're going to use here. So first, I want to define conjugates. So if a plus b is called the conjugate of a minus b, and a minus b is the conjugate of a plus b. So they're conjugates of each other. Okay, so they're the same except the sign in the middle is different in one of them. Different in one from the other. So, difference of two squares. So this is a factoring formula. If you have a difference of two squares, a squared minus b squared, then that always factors as a product of the conjugates, the quantity a minus b times the quantity a plus b. Always factors that way. So these are some of the easiest ones to factor. You just have to keep track of, in this first term, what is being squared. A is being squared. So the number that goes here is A. Here, what's being squared? B is being squared. The number that goes here is B. I would put the minus one first and the plus one second, just because when you do some more complicated stuff, this first factor will still be A minus B. Like if you do a difference of two cubes, difference of two fourth powers, difference of two fifth powers. We're not going to do those in this class. You'll do it if you take a pre-calc class, at least the cubes. So these numbers are the numbers being squared, not the whole number here. Okay? And that's true whether there's variables involved or not. So it's a product of conjugates. And we use this a lot. So I'm just going to check it real quick just to show you that it works. So I take a times a, I get a squared. I take a times b, right? A times b, I get ab. Then I'm going to take negative b times a, and I get minus ab, or minus ba, same thing, right? And then I take the b, the negative minus b times b is minus b squared. And then notice these two are actually the same. You can flip the a around. So it's ab minus ab. So those middle terms cancel, and you end up just getting two terms, both of which are squared. Okay. So I have a couple notes here. First, the difference of two squares is the only way to obtain a binomial from multiplying two binomials. So we call this the difference of two squares situation, whether it's written this way or this way, right? It's a difference of two squares. It's just this one's written differently. So notice if you take the product of these two binomials, you get a binomial. And this is multiplying conjugates is the only way that's going to happen, because that's the only way the middle term will be 0. They'll cancel out, see? Anyway, that's my first little note. Second note, a sum of two squares of degree 2 with no common factors does not factor with real numbers. You can factor it with something called complex numbers that we'll do later, but you can't factor them with real numbers. What does it mean? Let's see. A sum of squares of degree 2. Why the degree 2? Isn't a sum of squares also degree 2? No, because a up here could be, for example, a could be a squared. Then you'd have a squared squared, which is a to the 4th. And b squared, b could have been, wait, let me say that again. I think I said that wrong. A could be something like c squared. Then this expression would be c squared squared, which is c to the 4th. B could be something like d squared. And then that would be d squared squared, which is d to the 4th. So if you have c to the 4th minus d to the 4th, that's still a difference of two squares. It's the difference of two 4th powers, but you can also think of it as the difference of two squares. And that one actually factors. Any difference of two things that's order 3 or higher, with the both cubed, both 4th power, both 5th power, those all factor with the difference in there. Actually, for 3 or higher, they always factor with plus in between as well. With the minus, the first factor will always be this, and then there'll be a bunch of terms out here if there's a higher power. But anyway, that's why that's there, because if this is a difference of two squares, and this is a 4th power and a 4th power, then it does factor. And this is saying it doesn't factor if it's only degree 2. So like if this is x squared minus y squared, or x squared plus y squared, it doesn't factor. With the minus it does, but not with the plus. X squared plus y squared doesn't factor. And if it has no common factors. So maybe I have some examples we'll see.